Hello and welcome to week 013. Just found a typo on my slide. We're getting close to the end. I can't believe all the things we've gone over. I went through and looked at the slides for the first 12 weeks, and it is a lot between all the big data, all the LLMs, vectorization, topic modeling, LDA, dimensional reduction. We've gone over a ton of stuff. And I really hope that this adds value and that you can incorporate this and use this and eventually get a job and make lots of money. That's really the end goal for all of us here, is to get a job and to be happy. And those are the first two goals. And then to incorporate money into that process. Because if you get a job and you're happy but you don't make enough money to live, you won't be happy. So I really hope really hope this class adds more than academic value and adds real life value to that. That's one of my really big goals, is not just to create a theory of learning or an educational, not to do this just to teach. I really hope that you have some takeaways from this class that will add value, that are marketable tools. I made a video last week about how you can take your projects that you've done for this class, ask ChatGPT to write a LinkedIn, post, and do that. And after that LinkedIn post, I got two jobs, like, hey, please apply for this. One was for 120 for a data scientist, and the other one was, I didn't tell me the price, but it was for something. So I literally took, I think it was that BERT topic, and I asked ChatGPT, hey, can you make a project, blah, 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 on this, post it to LinkedIn. And in the job video, I showed how to do the whole process, and two people hit me up saying, hey, can you apply for that? You're perfect. This is exactly what we want to do. So please, take some of the projects that we've given you, ask ChatGPT to write some type of, or Claudia or somebody, or you write them yourself if you're really good at English, write a description for LinkedIn, post them at least once a week, and you start getting your name out there. I really want to see you all succeed. That's super vitally important to me. So let's see what we got this week. Okay, so the teach back. The teach back it is so hard to explain the teach back, but it's so vitally important. At the end of the day, 10,000 overfoot picture of this is I want you to be able to talk to coworkers or people, and I want you to be able to express a technology idea, and I also want you to express, here is a problem and this is why it's better, if that makes sense. So let's start with number one. So in data science or in computers or in business, it's vitally important to communicate ideas to peers. Not just communicate, because that's kind of, in my mind, that's a BS topic. We want somebody with good articulation skills. No, you want somebody that can, because communication skills, to me, are important, but they're not vital. What I want is I want somebody that can take an idea and sell that idea, explain that idea, take his idea of why something should work, and convince 10 other people that, hey, this is a great idea. My idea is best because of X, Y, and Z. Once you can start developing those skills, or the sooner you can develop those skills, the sooner you'll have a better paying career. You'll be able to have a team of people that you love to work with, that want to see your project get to the end line. Like I said, the technology idea, I really don't care. As long as it's something just nerd related, computer related, I'm happy. But the thing too is, you have to explain why what you're doing is better than what we're doing now. That's really big in business and in life and a lot of things. Hey, this is what I'm doing. I'm doing it because this, while it works, it's not great. Okay? Henry Ford had to basically do the same thing. I have a car, it only maybe goes 10 miles an hour, but you don't have to feed it like hay like a horse. It can go longer. It's cheaper to maintain. They don't die. So you should buy my car to transport milk. It's a very succinct argument. Here's a horse, what you use to transport milk to people. I'm Henry Ford, and I invented the Model A, and it's better because of X, Y, and Z. Look at Tesla. Okay? Whether or not you love Elon Musk or hate Elon Musk is irrelevant. He came out very articulately and said, hey, an electric car is better because A, B, C, and D. They're cheaper, they don't have as much maintenance, they last longer, they hold their value, they're better for the environment. Now, whether or not all those things are true or not doesn't matter. He came out with bullet points of why Tesla was a better car. He did the same thing with SpaceX. He went out and to say to SpaceX, hey, we can fly things to space cheaper than the government. Why? Because we don't have as much bureaucracy. We can be lean and efficient. NASA's working on computers from the 60s. We can buy new computers and start from the ground up. We can be fresh. We can be agile. We can hire programmers, since we're basically in Silicon Valley, and make machines better. We can reuse rockets. This is why all these things, why SpaceX is better than NASA when Elon Musk presented the idea. He didn't just say SpaceX is better and SpaceX has big rockets and we have these big engines and we're going to be really cool. No, that doesn't tell me anything. He said SpaceX can do it better than NASA because we're going to reuse our rockets. SpaceX is going to save money compared to NASA because we can hire people cheaper and we can fire them faster. We're more lean, we're more agile. He gave very succinct reasons. That's what I'm hoping you guys can articulate in your teachbacks. I'm doing this because this method, while it may or may not work, this method is better. Okay? Again, I want you to upload a YouTube video or a collection of short videos, TikToks. You can send me the link to the video. Hey, youtube.com/blah, blah, blah. You can unlist it or you can make it public. I don't care. But if you make it private, then I won't be able to see it. Any related material. Some of you have a couple of really cool ideas. If you guys want to share your notebooks, that would be great. Maybe like an outline, which everyone did fine in class, so just do your outline. So, and I also kind of need to know what teaching level. Hey, I'm teaching it to coworkers, I'm teaching it to kindergartners, I'm teaching it to nerds. Who are you teaching it to? So that's the teach back. Please don't forget it. Let's celebrate. These are questions that you've asked me to help you elaborate, to help you understand. So before we get to this, what is my first one? The plan. Okay, right here. I've been at the job, my new job, for 2 weeks now. And I will tell you, so in the old job, I did all data science stuff, but it was still very structured data. I mean, not all the time I was working with structured data. I did a lot of things with ultrasounds, which are pictures and cinemas and videos. I did some other non-structured data, okay, or unstructured data. My new job is very, very NLP, very, very unstructured. And I've worked with, I don't want to say higher management, but I've worked with a different set of managers now. I'm really seeing the value of unstructured data. In the past, I've told you, hey, if you really take all the data in the world, 20% structured, meaning it can fit in a database somewhere, or it's, clean, or whatever you want to call it, 80% is unstructured. This video, once I upload to YouTube, is unstructured. The PowerPoint, if I take it and export it and take every slide and say slide 1, slide 2, slide 3, and copy everything on that slide and put it in Excel, that's structured. Okay? I'm working with almost exclusively, I'm pairing up unstructured and structured data to get insights from a lot of the unstructured data. And really, I've seen and learned just so much, or that there's so much value in unstructured data, and that businesses are really aggressively going after unstructured data because they see the value of it. I think this is going to be through a lot of different companies. So a lot of the NLP stuff we're working on is all unstructured. A lot of what you're doing is all unstructured data, and I think there's a huge business value in that. So just please keep learning. You guys are doing great. So a couple things we're going to talk about. GANs. Somebody asked me the best AI platform, and this is such a hard one. I've been looking at this because somebody asked me to write an abstract a couple weeks ago, and I hit this problem before. Cloud computing, scraping and ripping. I didn't come up with a really good example. I have one from last semester, but I can't find it. So I might do scraping and web ripping on another one. I have a little tutorial that I think I'm going to throw in another video about how to run local LLMs. So these two, I guess on this side right here, I don't know if you see my mouse, right here, will be either next week, different video, something. Next week we're going to cover multimodal, and it's just, oh my God, every time big data, stable diffusion, transformers, there's just these major breakthroughs, and it's scary. So you guys have seen Sora, however you say it, Sora. Let me get it loaded up. Okay, so Sora is, I typed a prompt. Like I said, I think I've talked about this, but you type a prompt and it makes these really cool videos. And we're starting to see some more demo videos. So this is not computer generated like CGI. It's not made from a wireframes. It's made from a prompt. So somebody typed in, a stylish woman walks down Tokyo, and look at this. This is what it made. Okay, look at this one. Historical footage from California during the gold rush. Now this is completely made up, no wireframe. This is just what the machine interprets the video or the prompt to look like. Pretty cool. The camera following behind a white vintage SUV with a black roof rack as it speeds up a steep dirt road surrounding pine trees. Okay, so now really, one of your questions or business questions, I don't know if I've seen this one. What a cute puppy. One of your first questions should be, what is the business value of this? Well, let me tell you. Imagine that I own a business and I'm having customers have problems ordering things. Now, I can dynamically generate a video on how to do something. That'd be amazing. So, 3 weeks ago, 4 weeks ago, longer than that, probably 5 weeks ago, I was having a problem with an AI video or an AI problem. Some algorithm I was having a problem with. And I talked to the company, and they sent me a video that was 3 years old on how to get my Windows log files and a couple other AI stuff. I'm thinking, and it was like hosted and weird. It was just a horrible video. And I'm thinking to myself, here is a multi-million-dollar company with hundreds of employees, and this is the best you can come up with for a video. I mean, it literally looks like a 2-year-old captured it from a cell phone. It was horrible. And it was bad. What if I go to McDonald's and want to order something and I don't understand, like, how they're going to the prompts, like the touchscreen things? Now I can make a video. Can you help this person? And you can take a picture of that person and dynamically insert them into the video. Hey, this is how somebody like you would order this. What if, my job as a teacher now, I'd be like, hey, make a video that shows how GANs work. And blah, blah. I mean, think about this. There's so many business opportunities for real-time video generation. It's just endless. It's just endless. And while I know Las Vegas is getting a couple of movie studios and everything else like that, dude, this looks movie quality to me. And all you need to do is have a dude sit in his house, type some prompts. I mean, I hate to say that, but it's true. Look at it. I'm sure it's not as easy as that, but still. So multimodal is a really big thing. And going on that, I just saw that they have a voice. Let me get it here. Just released a couple, well, it's not released, but opened last, 3 days ago. Yeah, so March 29th, so 7 days ago. So from what I know, this is not open to the public. I've tried contacting OpenAI. They don't seem to give me any love, and they won't let me see any of the private models, at least yet. So basically, from what I know about this model, is that basically, I guess I can upload a person's voice for 15 seconds, and this will generate, then I can type whatever I want and have that voice say it with just 15 seconds of audio. And translate it to different languages.
As a bilingual individual, fluent in both English and Portuguese, I'm contributing my voice to the Livox project. This recording is intended to assist non-verbal individuals in expressing themselves more fully, while preserving the nuances of both languages.
Okay, so let's see what the machine generated.
Can I get your attention? Thank you for your help. Can we watch a movie tonight?
It sounds almost the same.
Please help me find my glasses.
I mean, just think about that. Helping patients recover their voice. For those suffering from sudden or degenerative speech conditions, the Norman Price Neuroscience Institute of Lifespan, you guys want, one OSA Neuroscience, this is why. They've been piloting a program offering voice engines to individuals with ontological or neurological etiologies for speech impairments. I mean, current voice.
Hi everyone, this is what my voice sounds like using open.
Then let's see what is generated.
Hi everyone, this is what my voice sounds like using OpenAI's new text-to-speech model.
So like I said, multimodal, well, we don't think about it a lot because we just think it's, I don't want to say a dumb toy. It is just, it's going to really change the business too. So I could spend a whole class teaching multimodal. It's really something I'm very passionate about, but it's just amazing. So let's talk about GANs. Um, GANs are hard to teach and kind of tricky because 98% of the deepfakes are GANs, and probably I think I read somewhere 93% of them are adult in nature. You know, they're the Taylor Swift sex tapes, things like that. So it's a tricky situation, but GANs used outside of that are amazing. They're just phenomenal. So one of my first introductions to GANs was somebody asked me if I could detect COVID, or I saw some type of project on COVID using X-rays. And when I had the data set, it was only 75 images. I think it was 75. It was less than 100 images of COVID detected in X-rays. Now there's thousands of them. So I use a GAN to kind of artificially make a bunch of fake COVID X-rays, and it works beautifully. Okay, so GANs, Generative Adversarial Networks, was invented by Ivan. I always get his name wrong. Goodfellow. I know he's at Apple. He left for a while. Basically, what it is two neural networks fighting against each other. Okay, you have a generator, and a generator basically his job is, here's a word, take a vector, a random vector, and make it into an image or generate output. And then discriminator to look at that vector, to look at that output and say, hey, it's real or it's fake, and here's why I think of that. Okay, and then feed it back to the generator. So the analogy that everyone uses, this is a good analogy, is that you have a forger, either a counterfeiter, a guy that makes fake $100 bills, or an art forger. Okay, he makes his first $100 bill and hands it to, let's say, a Secret Service agent or to an art critic, and it looks like it was drawn by a 2-year-old. Like it's in crown, and through the discriminator goes, this sucks. It's in crown, it's horrible, it's bad. The generator does it again, and then does it again, and does it again. Well, how long would it take you to draw a $100 bill that eventually would get so good that nobody could tell? 10 tries, 100 tries, a million tries, a billion tries? And this is computers. You have to remember too, with computers, we're talking, they don't try 1 or 2 times. They try millions and billions of times. So GANs, just to be forewarned, are very computationally expensive. They take a lot of time to do, most of the time. But the idea of having 2 machine learning models say, hey, I'm trying to make a fake here, and this one's trying to detect a fake, is amazing. Because then you get these really, really, really great outputs. Now, besides deepfakes, what can GANs do? Well, image generation, but stable diffusion transformers can't take that out. But fake medical data. Now, I have a sample of this for you. Okay, how do you generate fake medical data? Think about that for a second. I mean, 'cause I can't really give you, the students, or my coworkers or other people, real medical data. That's against the law. So if I want to teach you how to become better at working in healthcare and being in data science in healthcare, or financial in money, it doesn't really matter, same privacy rights, how do I do that? I can't give you data, so if I can't give you data, how are you going to learn? Well, GANs can create beautifully fake data that's basically indistinguishable from real data. Now, once we train these discriminators, once we train one of these machine learning models, we can really start training that to start looking for anomalies. Because it's seen millions and billions of fake things versus real things, it knows the difference really, really well. So if you were to give me a real Picasso and a fake Picasso, I couldn't tell the difference. I mean, this was really bad. But I mean, if they were both really good, I couldn't tell the difference. I couldn't tell the difference between a really good $100 bill and or a real $100 bill and a real good fake $100 bill. I mean, looking at them, I couldn't tell because I haven't seen a million, I haven't seen 50 million, I haven't seen a billion fake $100 bills. But after seeing let's say a billion fake $100 bills, I could spot the difference between a fake one and a real one instantaneously. Well, what if I take my skill as a person that can detect fake $100 bills and apply it to something else? Anomaly detection. They're also very good at de-aging and aging people, much better than any other model. Data augmentation, that's like what I told you about with COVID-19 data. And there's a bunch of data sets out there that do this now. Also music creation, surprisingly or not. They're very, very, very good at creating music. Okay. So let's, I have a couple sample videos. So in a nutshell, I don't want to get too math technical heavy here. Because I got other things I want to teach. But I really do love GANs. And I think GANs are going to play a big role in the future because somebody asked what's the best AI. I think part of the best AI is going to be a distributed AI. And I think GANs are going to play a part in that. Okay. But basically, we have a random vector. Okay. And we pass it to a generator, a forager. And he creates an image. And trust me, when you see some of these GAN images, they're all staticky. They're really bad. Here, let me see. Yeah. I don't know if you can really see this. You try to make it better. Okay, so here's the ground truth. This is what the detector is trying to compare against. Well, me, I can see that this one right here, Epic 1, versus this is just horrible. I know that, I mean, look at it. They're not even that similar, okay? Now, half an hour into the training, 50 epochs. Oh, getting better. We still kind of got that weird And we go on. And see, I mean, we're at 4 hours, 6 hours. Now, at 8 hours, the first one actually looks kind of like a sunset picture. Now, some of the other ones don't, but it's getting much better. Okay, so GANs, I mean, literally, just, they do it so many times that they get better and better and better and better. Okay, and you, again, here's training process. And again, you see this in older 2060. Here's your ground truth. Boom, boom, boom. After 500, it's getting, I mean, it's getting much better, you know. So basically, you generate a random vector, you generate an image, and then you have a discriminator that basically looks at this and kind of freezes state. The generator tries to minimize the loss. So what the generator does, basically, it takes feedback from the discriminator and says, hey, I want to minimize loss. I want to minimize the number of errors. Okay? And by minimizing the number of errors in that vector, the image it generates or the sound or anything else, it gets better over time. Hey, let me try this. Oh, it didn't work. I get penalized. Let me try this. Oh, that worked. Let me keep that. Let me go on. That worked. It didn't work. It just does that millions of times. Okay? So that's basically going to...
Entering an era in which our enemies can make it look like anyone is saying anything at any point in time, even if they would never say those things. So, for instance, they could have me say things like, I don't know, Killmonger was right, or Ben Carson is in the sunken place.
If you go on, you can see
Moving
right
forward,
here.
we need to be more vigilant.
And this is
with
like a
what we trust from
5-year-old
the
video.
internet.
This is not anything
It's
new.
a time when we need to rely on trusted news sources.
I am not Morgan Freeman, and what you see is not real. Well, at least in contemporary terms, it is not. What if I were to tell you that I am not even a human being? Would you believe me? What is your perception of reality? Is it the ability to capture, process, and make sense of the information our senses receive?
So here's another example of that, because I don't know how long the deep fakes and the whole, you know, I don't know if there's a lot of business value in that. But here, Synthetica, there's a huge business value in it. Let me pull up some patient data and show you real quick. But yeah, so anyways, and I honestly don't know if Synthetica uses GANs, but It's an amazing product. I use it. It's very similar to GAN output. Basically what you do is you tell it, hey, I need 10,000 patients, and it uses Java and a few other things and creates patients, okay? Did I include a sample here? No, I did not. Let me grab sample data. Okay, output, CSV, and allergies, care plans, claims. I was looking at claims data, but let's go to payers, providers, in a small table. Did I click it open? Okay. So we know that nobody's real name is Hank 686 Yost 751. We know nobody's real name is Alan 198 Moore 220 or 224. Sorry about that. Okay, but this is a sample of the data it generated for doctors. So these are all, let's say, general practice. I don't think I include any specialties in here. I said just do the whole thing in Nevada. Elko, you have Laughlin, Earring, I mean, even small towns, Battleborn, zip code. So I guess one of the really first things to do is check to see if, we want to do Reno, if this is a real address. Yeah, look at that. Reno, so it's a real hospital. I mean, that is, so somehow it was trained and knows that this is a real address in Reno. Let's try Elko, a real smaller town. Ely. Ely is a super small town, even smaller than Elko, okay? So 1500 Avenue G. Yep, got the same. Let me make sure the zip codes are right. 89. So it looks like you got the zip code wrong. 89301. No, I got it. 89. Got that right. So yeah, I mean, it just generated that data from past data. But look how accurate. I mean, it found. Sorry, let me go back here. It found, I mean, a nursing home, and it generated the data from that. No, not all these are going to hit. Not all these are going to hit. Oh, look, it's like almost. I know that this is not in Pahrump. I know that that's in Las Vegas. But let's see. Yeah, Las Vegas about. So see, look right here. Didn't get this one right. Because I used to work at 2916 North Tenaya on Las Vegas, and the zip code was different. It was 89129. I don't remember 89. Whatever. Optum, Las Vegas. Yeah, 2617 Tenaya, and this is 29. So I mean, I know that that's not in Pahrump because I didn't work in Pahrump. So I mean, it's not perfect, but I mean, it found. I mean, I can Google a couple more of these and show you that hey, it's going to find really good addresses for the way the GANs work. Elko Family Medical and Dental. Okay. So that shows you how powerful this is as a training tool. I can get you real good data with a GAN. And that's just one. I mean, there's financial generators. I mean, this is why GANs are important. Like I said, and basically what happens is it starts making addresses. Then the discriminator says, no, that address sucks, that address sucks. You know, that one's good, that one sucks, that one's good, that one's, and it does this millions of times, and it generates these ultra-realistic addresses, as you saw. It's not perfect, but it's great. So, I think GANs are going to play a big part in the future because of this. So, one of the students asked, what's the best AI platform? And this is such a hard question to answer, okay? So,
For that, we need
before I answer that, I want to go into a tensor imaging, okay? Because I really think this is going to play a part in the future. So, if you get an MRI or a CAT scan or anything else like that, it's basically a one-time picture. Tensor imaging shows the flow of information between different parts of our brain, okay?
ETI.
I mean, I can give you this whole video if you guys want to watch it, but let's see.
To create this, we need to do a few more things. axons in the white matter,
But basically, these
showing all the
tensors,
white matter tracts of the brain. As a
so
final
that's actually
touch,
how
we
we
can use
think.
the
That
Emerson
tensor is
colors,
how
which
we
represent different
interconnect.
directions of the 3D space. Now, that's it. We hope you enjoy.
Now, why did I tell you this? What is the point of this? Okay, I don't think, and I could totally be wrong on this. I don't think large language models are going to be the end-all generative AI. I think what you're going to have happen is that these models route between general models and specialized models. There's something called RAG. I don't know what it is. Retrieval augmented generation, maybe. I have to look that up. But a RAG basically goes out and kind of gets domain-specific information to augment an LLM without fine-tuning. If I don't know the question of X, I can go to Y and augment my LLM or myself as an LLM. Okay, so also answering the question of what is the best LLM, I know that Humane AI and a few other companies are working on ways where once you ask a question, it tries to figure out the intent of that question, and then based on the intent, it routes it to different AI models. If it's a programming model, maybe it goes over to ChatGPT, OpenAI. If it's an understanding model or business model, maybe it goes over to Claudia. Okay. There's this router bench that talks a little bit about that, and there's also a comparison of the two. But it's really, really hard to figure out what the best model is. I've seen people talk and do like pseudo tests on Reddit. I'm not sure I always trust them. There is something I'm going to show you here. This. Okay, let me pull this up and show you why I like this. Okay, so this, and you can do, there's another one where you can actually use ChatGPT 4 and Claudia and a bunch of them. But this, I can type my prompt out. What is the, what is the difference between RAG and fine-tuning a LLM? Can you make a table or explain and explain it to me like I am a high school student? Okay, so I'm going to send it to Meta's Llama, and I'm also going to send it to Minstrel Small. Let's find another model so we're comparing more apples to apples. I think this is a 7 billion. I think so. Now we're both comparing it to two different 7 billion parameter tokenized models. Okay, so I'm going to send the exact same prompt, all the same misspellings. Let's see, here we go. And then I can look at the time. I can look at the response. Okay, let's make a table about the pros and cons of Mac versus Windows. So let's go medium. Ooh, I guess I don't want to do that, but whatever. And then Google's or Gemma right there. Okay. See, now you can see the difference. Look how much faster this one is compared to this. But this one actually made me a table like I wanted. This one did not. Okay. So I think in the future, what's going to happen is a lot of people are investigating the differences in these AIs. Okay. And then, make this a little bigger. I think what's going to happen is there's going to be some type of routing. I think Google does this somewhat, and I think ChatGPT 4, somebody told me that ChatGPT 4 is actually a bunch of Chat 3.5s kind of differently trained and knowing different domain areas, and that Chat 4 basically just routes your question to kind of like a specific 3.5. Whether that's true or not, I don't know, but that's kind of what I've heard. So it's how we as humans think. That's why I showed you that tensor video in the beginning. When we talk, we use certain parts of our brain. We don't use our whole brain, we just use certain parts. when we smell things, when we have to think computationally, when we have to write, we use different parts of our brain and we send data between the two parts. And that's why there's that lie, oh, you only use 3% of your brain or whatever the stupid story is, or you only use 10% of your brain. It's not true. You use all of your brain. Okay? You may not be using it all at all once because you're not listening, talking, walking, jumping, doing math all at the same time, but you use all parts of your brain. Now, as you know, some LLMs are better at X, Y, or Z. So let's say that OpenAI is better at code questions compared to Claudia. Well, we know the same thing is true in the human brain. That there's no such true thing as, hey, this area right here is the only place that I do calculus. And if I lose this area, I'll never be able to do calculus again. Well, you can remove that part, and yeah, you might have to relearn calculus. You might never ever be as good as you were, but you can regain some of those skills. Hence, Claudia may never be as good as OpenAI at code, but it will still kind of function. And that's kind of how our brain is, There's a lot of similarities between routing to different LLMs and the way our brain works, okay? That's why people that have stroke and literally lose parts of their brain can still function, because other sections kind of pick up for it. That's also what makes picking up certain diseases very hard, because other parts of the brain pick up for those deficiencies. And I think if we're really going to achieve general intelligence, GAI, general artificial intelligence, this is going to be a big part of it. Hey, we're going to have an AI that's really good at X. We're going to have an AI that's really good at Y. We're going to have some type of router between all of them. Okay? So I don't know if there is a better AI. For me, I pay for all, like ChatGPT, BERT, or whatever it is, Gemini, Claudia, and I use them all differently. Okay, so for very large tokens or for very professional things, I personally use Claudia a lot. I really am in love with Claudia. Anthropomorphic, I think that's just a great AI model. For coding, I love ChatGPT for more technical questions. I use OpenAI also for things that require access to the internet. Real-time information processing, more nerd stuff, I always stick with OpenAI. Okay? But again, once this class is over and 6 months has elapsed, things will be completely different. I will show you Llama. It looks like some of the software that's basically powering that this site. I don't know where it's at. Versal. Okay. So I've been using Llama a lot. It's basically a way you can download and run models and do a lot with your local machines with LLMs. You literally say, hey, use a Llama, use this model, use that model, and it works great. I've been using it a lot. In my personal, I haven't been using it at work, but in my personal life, I've been using it to do a lot of things. And it's a really, really nice model. So it's like that LM Studio I showed you last week, but it works on Macs and PCs. So I'll give you guys a separate video on that sometime. I think you'll really like it. But once you start playing with each model, you know that each of them are different, has their skills. Each person's different. Each person has their own set of skills. That's why I try not to pigeonhole you into or cubbyhole you into a certain way of thinking or doing. That's really the only advice I can give you for the best OpenAI. Okay. Cloud computing, 38 minutes. Okay, so, cloud computing, So, I've been using AWS for years, probably over 10 years, I can tell you that. We're right at 10 years probably. And I love cloud computing, I love AWS, but I also kind of understand the pros and cons of cloud computing. I think once you take a step back, that's why I put this particular video in, and once you get a 10,000 foot overview, you can make analogies, then you can kind of understand the good and bad. Here's some of the bad. So in my new job, if it was prim, it'd be much easier for me to get access to the data. Okay, it would. I'd be able to just call somebody and say, hey, give me access to this, boom, I'd have access within a day or two. my new role, it's been 2 weeks. I'm still fighting to get the correct access. Now, on the opposite side, on Friday, Thursday, I created a 300 gig table in like 30 seconds, not even that, maybe 15 seconds on Snowflake, blazing fast. I don't think that'd be possible on-prem. So there are pros and cons. I've cooked hamburgers, and this is where I'm going to go with this. I've cooked hamburgers for myself hundreds of times in my life, and I've also gone to In-N-Out Burger last week. Okay, so why do we, as a society, why do we go to McDonald's? Why do we go to In-N-Out Burger? Why do we have fast food? What is the purpose of fast food? A lot of people know how to cook. We all have access to grocery stores. Most people have access to grocery stores. It's a lot of times cheaper-ish to cook our own food. But why do we eat at fast food? Another analogy is I have a pre-built computer. I have a Dell down here next to me. I also have a computer I made for Christmas next to me, a homemade computer. I used to teach how to build computers. Why do we build computers, or why do we buy pre-built computers? Once you can really understand all of that, and you can really answer that question really articulatively, that's not even a word, really succinctly, then you know why cloud computing exists. So I use McDonald's when I go to In-N-Out or other places, but I go to McDonald's to save time. For me, I'm willing to pay a little bit more money and maybe get a little less quality, in case of McDonald's, but not In-N-Out, because time is money. Time is money. If I'm hungry and need something quick, I can go to In-N-Out and get food in 5 minutes, where if I come home, it's going to take me half an hour, 45 minutes to prep it. When I build a computer, I get exactly what I want. Everything to a T, exactly what I want. A lot more headaches, and a lot more headaches. Where I buy a pre-built computer, a Dell, or an HP, or whatever brand, you might not get everything you want, but you get 90% of what you want. But it's just a click, and the next day it shows up on my doorstep. Click, doorstep. Super convenient. And in that time, from, hey, I want to buy this Dell, boom, I can be working on other things that make me money, instead of fighting with building a computer. So, let me keep going on a little bit more about this. So, if you really look, in my mind, the way I split everything out, there's kind of three big players. That's Amazon, and I don't know how accurate these numbers are. I never trust numbers, but let's say Amazon controls about a third, then Microsoft, which is Azure, and then Google, Google Cloud. I have another name for it. Those three control over half the market. And it looks, when we look at it, the next 20 companies only control about 20% of the market. Amazon's really the one I probably know the best. The second one probably is Google. Just a lot of programmers use Google in Silicon Valley for some reason, and it's a really nice service. Then a lot of businesses use Microsoft. Okay, so what happens, or at least what you see, is that companies try to have a whole streamlined approach. So if we're using Microsoft Outlook as our email server, we'll use Microsoft web servers, and we use Microsoft Azure products. If we use Google, like UNLV uses Google for our email provider, then we use Google Drive for our file destination. We use Google Cloud for other things. We use Google Calendar. So we try to have this whole integration. It makes life a lot easier. So when you look at companies, or when you move, or when you work with something, you know, hey, if I'm getting an Outlook email, they probably use Azure. If I get a Gmail account, they probably use Google Cloud Compute. Now, there's specialty players, and this is where this becomes really interesting. Like Heroku, I've used them a lot. I mean, I still use them today. So they're more of a programming-focused deployment service. So I can go to them and very easily set up everything I need to deploy web servers, because they focus on like Ruby programmers and Python programmers to say, hey, here's everything you need very easily to get your app scaled and out the door. Lambda is Lambda Labs. They're machine learning. They used to build computers. They probably still build computers. But now they spend a lot of time on developing cloud. Now why? Because if I was going to do some type of training, I can include a Lambda key and blah, 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 just type in a few letters, and boom, my code and my data automatically goes to them. They process it and I get it back. So I don't have to have, any of these really super expensive GPUs in my machine. I don't have to use a lot of power. I don't have to use anything. I just boom, 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 boom from my laptop or my iPhone. The data goes up somewhere in the cloud and comes back down. Paperspace is the same way. They're like a notebook-based provider. So they're just like Colabs. Also, let me check. I think a lot of these, or some of these, run on Amazon. Yeah, I know a couple of these. Maybe it's Heroku. Some of them, instead of building their own data warehouses, they basically just use like Amazon's data, and they rent enough machines that they can offer a discount, and they install specialized software that makes their servers run better. Okay. So you remember, a lot of these bigger companies have to market to everyone, where some of these smaller companies can kind of market to a certain type of programmers or things like that. So that's how I kind of break everything out to start with. Okay. And I mean, they have every type of service. Okay. Oh, how can I put this at the end? One huge benefit about Google, Microsoft, and Azure. So my brain just froze. They love to have people use their platform. So I think UNLV has a partnership with AWS. I know I won an AWS award as an undergrad 8 years ago, something like that. I was the first one to win it. But basically, one of the things I did was set up a Windows machine, a really powerful Windows machine, to do a lot of processing in the cloud. I had a Windows machine at UNLV, but I just need a lot more RAM and a lot more processing power to look for what I was looking for. I was running Tableau, then I moved over to Ruby. And so I just used Amazon literally to make a really supercomputer, powerful Windows computer. But going back to training, all these programs, I know Google and Azure have a ton of training, a ton of certifications. They'd love to teach you about their platform, because what they're hoping is that they'll hook you and you kind of get used to that platform. So for me, I love AWS. I know AWS. I feel comfortable with AWS. At my work, we use Azure, and it's just, for me, it's very clunky. It's hard for me to move around. It just doesn't feel right, okay? I'll get used to it over time, and they offer the same thing. They do the same thing, more or less. But companies really do try to get you to learn their platform and know it the best, because if they teach you how to use it, they make money. And the better you use it, the more you're going to use it, the more money they're going to make. So they have a direct vested interest in teaching you how to learn about it, okay? Last semester, I had a little server up. Initially, I installed it on one of my home server machines. I have a little server and a fiber optic cable from Cox. And I saw that at home, and I'm like, no, I don't want to do that. Then I moved over to AWS and rented like an RDS, a regional database, whatever that is, put it up on there, and then I moved it over to another product at Amazon, and then I moved it back to, I think, an RDS. I don't know, I moved around a couple different times at Amazon. I think I paid $40 a month, and I mean, maybe that sounds like a lot, maybe that doesn't, but for $40 a month, I can have all my students access it 24 hours a day. I know it's never going to go down. They back it up every day. I don't have to worry about my power going out or my internet going off or nothing. I know that the whole class could access it all at the same time, and we're scaling it bigger automatically. I don't have to worry about anything. And for me, $40 a month is worth it. Where at my home internet, it's 500 megs a second. If everyone hit it and started using it a lot, it might slow down. Or if I'm downloading something, why did my video stop? Weird. It looks like I just froze. But if I'm downloading something, it could not work. So again, that is why I use AWS. $40 a month, all my problems have gone away. So we have next. So again, this is just an overview of some of the services they all have. They all have different names, but they all basically do the same thing. You know, they all have compute services. So instead of saying, hey, I'm renting CPUs, they call, hey, look, I'm renting an EC2. I'm using a virtual machine. I'm using a compute engine. And that's what makes it sometimes hard to kind of understand the difference between these two. Like in Amazon, it's Route 53. Route 53. So, you know, hey, I want to have a richardyoung.com. You know, I don't know. So, you know, at Amazon calls it Route 53. No idea why. They just call it Route 53. Well, Azure calls it Azure Traffic Management. Kind of weird. Google makes sense. Cloud DNS. It's a DNS service. It's a Cloud DNS. So see, they all kind of do the same thing. They all kind of do it slightly different. But it's, you know, that's what makes it hard. But again, it's very similar. It's just kind of what. So CDN, SQL, we've been, you know, worked on that a lot this semester. NoSQL is like kind of like JSON databases in a way. Virtual networking, like a VPN. I don't know if you guys know you can VPN to UNLV. We can also VPN into a private network that's closed off to other people. I mean, a bunch of things. I mean, AWS has satellites. They have quantum computers, everything. So now, when you think about computers, or cloud computing particularly, you have to kind of understand what you're buying or what you get. I thought I had a little slide on this in the past, but if not, let me just go over this real quick. Infrastructure as a service, you're actually renting the hardware, not really hardware, you're renting the roads, everything else like that, okay? You're renting everything you need to run a computer, but they have really no part of it. So I can install software, I can delete software, maybe I'm responsible for my own backups. Basically, I'm just renting a little computer in their office. Okay, infrastructure as a service. A little more complex than that, but you get the idea. Now, platform as a service. So we've all used this. Now, Google Colab kind of floats between a platform as a service and a software as a service. I consider a platform as a service. So let's talk about when you guys use Google Colabs. For the most part, you didn't have to buy any computers. You didn't have to buy any internet. You didn't have to license any software. You didn't have to get a web server to serve it up. You just went to colabs.google and boom, you could start coding. Now, a friend of mine teaches a class, not here at UNLV, another university, and he makes his students install all the software, like literally Python, Jupyter Notebooks, and he spends 3 weeks, and it is the biggest nightmare he has to deal with the whole semester. Some students are on an old version of Mac, some students are on a new version. He has students that don't have English set on their laptop, so they're using non-English language like Chinese, and he has problems installing. It is literally a huge problem. He spends, I'm not joking, 3 weeks every day answering emails for 40 students to just install the same thing you had access to on day one for Colab. And it's kind of dumb because his students aren't necessarily programming students. They're not going to be doing this in the business world. It's just, you know, he used to do, you know, 10 years ago it was really your only option. Now you can use Colab. Amazon Beanstalk. Okay, so Beanstalk is a platform where basically I upload like a container. I upload something, and then Amazon kind of takes care of all the rest of it. If I need 2 servers, 10 servers, 50 servers, if I need multiple databases, they just take care of all of it. It's just kind of a platform. And it's, hey, life's easy. Okay. Software as a service. Okay. And we think about Gmail or Office 365 or GitHub. That is software as a service. So GitHub takes care of everything to provide me a service. They provide me a repository, a place I can check my software out at, or a place I can store my software. Gmail is an email service. Okay, so 25 years ago, something like that. No, 2003, I ran a bunch of email servers for the state of Nevada, for one of the universities. And it was a nightmare. Okay, so I know how to set up email servers. I know how to run email servers. But why? I can just go to gmail.com and get my own Gmail. So you have to think about the pros and cons. There's pros and cons of each of them. Gmail.com, I go there to get emails. Much, much quicker, much easier to deal with than setting up an email server. Email server, though, I have a lot more freedom, so how much work do you want to do? I go to McDonald's and I want tiramisu. They don't have that. I can't get it. Running my own email server, I can do some crazy things. Working at, running your own email server, you can do some crazy things like get tiramisu, I guess, compared to doing McDonald's. Sorry, kind of hard to come up with an analogy for that. And then function as a service, to me, these are API calls as a service. They probably don't want me to use that word, but they're API calls as a service. I pay for X amount of API calls, and boom. These are really kind of common in emailers. Hey, here is a list of 10,000 email addresses. Here's an email. Just make it happen. Okay. I have some Python code that whenever it completes, it just sends a text message to me. That's probably a function of a service. I pay like $5 for 200 text messages, and I have like my own API key, and basically I can run it anytime I want and get a text message. That's function as a service. I don't even have to log in, nothing. There's no login, there's no password. It's a pure API key. If somebody else gets my API key, I lose my money. So how do I teach you how to learn cloud computing? Because it's a big growing industry, okay? First couple things I'll tell you is that look at some of the training they have available. Like on the slide, 3 or 4 slides back, go through some of the training because there are so many different types of training that you can do. Just start playing with it. Most companies will, like Amazon, when I say companies, or Google, they'll give you like a $500 starter credit or a couple months free. Use it. You can set up other email accounts and open multiple accounts if you need. I didn't say that out loud, but I have 4 or 5 email accounts. I have my UNLV account. I have my Gmail account. My wife has a Gmail account. Dude, right there is 3 AWS accounts if I wanted to, okay? So that's one idea. Number 2 is also get a prepaid Visa or some type of like a rebate Visa card, and you can use that to sign up to AWS. So my Heroku bill this month was $18. Okay, so it's not like a ton of money, but it does help me to learn if I needed it to that $18 a month. Like I told you with my AWS is like $80 a month, and $40 of that used to be the database server. That's gone, so now it's down to $40 a month. So really, one of the best ways to learn a lot of these cloud stuff is to just get in there and play. I would not recommend using your normal everyday credit card because if you do something wrong, they're going to charge you a lot of money for that. Like if you get a big server and you don't turn it off and it's charging you, $80 an hour, then you run it for 4 or 5 hours and then now you're broke. So just get a prepaid Visa card, or like, hey, if you fill out a form, we'll give you a $5 Visa rebate card. Use those things; they work great. Another thing too is, okay, so you did some training and you have your kind of AWS or you have some type of an account. Now you're having problems. What do you do next? Dude, ask for help. Go to Reddit, and all those things have forums. It's great. So I had to set up a high security domain, and I had to use CloudFront, I think is what it was. And I was having some problems with some of it, and I just found it on, they don't have forums, so I looked on Reddit, and boom, found all the answers I need. So that helps a lot. Also, again, as I told you before, don't share your passwords, don't share your API keys, don't share your, none of that stuff with people on Reddit or anything else like that. That's, consider it like your house key. Okay, so also there's a lot of rewards. Like I said, I won an award 2014. I don't know when I won it for a big AWS machine. It was like a $5,000 or $10,000 award. They basically just gave it to me because nobody else applied. People, Amazon, Google, Microsoft, they're dying to get you on their platform. They are dying to get you on their platform. They're dying to teach you how great their software is. So they'll give you starter money if you need it to spend on they're called credits. So they'll give you starter credits. So they'll do everything. One of the companies I worked with in 2018, we had to do something, and we did it, and we got $75,000 worth of AWS credit, I think. So I mean, it's really, you just get credits really easily. So it's a great way to learn how to use a lot of these cloud platforms. They are the future. Let me go back one more. So let me go back to the motorcycle, whatever the front page is. So, for example, on my old job, I had one of the more powerful computers. I think I'm the only one that had an NVIDIA video card, and I have 64 gigs of RAM, and I don't know, like one of the newer computers. And in my old job at Optum, it was one of the more powerful computers. Now, since everything I do on the cloud is cloud computing, I generally use like 100 to 200 cores, so 10 times more powerful. And generally, we're talking 300 to 500 gigs of RAM. Just, I mean, the machines are just so much more powerful. So there is a lot you can do in the cloud, and it's important to use a cloud. I like AWS. I'm stuck using Microsoft. Does it matter? No. You know, I owned a Ford. I like Chevys. Does it matter? No. It got me to college and back. Does it matter? And they no. So, guys, please remember, Teach Back is due on the 14th. If you have any questions, email me. Study week. My only plan for study week, I'm not going to give you anything really heavy. I might do a lecture on ethics. It'll be optional. I'm not really sure what I'm going to do on study week. I don't like to give you guys anything that's hard. Maybe I'll make something fun. That's study week. And finals, again, don't stress about the finals. I think everyone did great on the midterm. You're going to do great on the final. My final's not there to make your life hell. My final's there just because it's required. I've been working in different companies for, let's say, 20 years. I've worked for the state. I've worked for, all different types of companies, and I've never had a final at work. So it is what it is. I hope everyone's doing good. Hope you all have a good week. Please feel free to email me any questions you have, and I'll talk to you soon. Thank you.